For the third module, we'll be discussing the language of algebra or the language of functions and relations. So mostly when we have the basic algebra, we will be discussing more on the variables. So variables are basically anything that represents a particular number or elements in a set. Okay. In your basic algebra, we are very particular when it comes to variables. So I discuss variables that variables could be letters, could be alphanumerical letters, or we have figures. Okay, we are fond to answering such puzzles in Facebook. So let's have the apples, 3 apples is equal to 18, and then we have apples plus bananas is equal to 14, and then bananas minus cherries is equal to 2. So basically, we could translate this one into an algebraic letters. We have x plus x is equal to 18, and then we have x plus y is equal to 14, and then y minus z is equal to 2, and then z plus x plus y is equal to unknown. These two problems are the same, however, it's more fun for us to answer such problems with a representation of bananas, apples, and cherries. But mathematically speaking, we are representing the problem into a variables. So we could represent apples as x, bananas as y, cherries as z. So it's the same context. However, it's more fun for us to answer this kind of problems rather than using algebraic letters, or we have the letters as variables. The main concentration of this module is for us to use letters as a representation of mathematical statement. So in the language of mathematics, we need to do translation or translating phrases into mathematical sentence. When we say addition, okay, these are the key terms. We have the sum, plus, more than, added to, or increased by. For subtraction, we could use the term minus, subtracted from, the difference of, less than, decreased by, and less. However, I want to point out the two important thing here. The order is important, especially the two terms subtracted from and less than. When we say a number subtracted from 5, this could be translated first the order, the second term first before the first term. So it is translated as a number subtracted from 5 is 5 minus a number, let's say x is the number. However, if this is a number subtracted by 5, the term is by, that is the time that you will take it as literally as is. So we have x minus 5. So make sure to know the difference of the term subtracted by and subtracted from. Same goes with less than and the term less. If we have to get a number, so a number less than 5, the representation is you write first 5 and then the number. So the representation is still 5 minus x. However, if there's no term as than or it is only less 5, so a number less 5, the representation of that one is x minus 5. That is very important when it comes to translating phrases. For multiplication, we have the term product, twice, times, multiplied by, or of. For division, we have divided by the quotient, the ratio, or divided into. Again, in division, order is very important, especially the term divided into. Okay, divided by and divided into are two different terms. When we say a number divided by 2, so this is x over 2. But if we say a number divided into 2, the 2 first would be our dividend and x would be our divisor. So make sure to differentiate, you know how to differentiate divided by and divided into. So if we have here addition, our variable expression is x plus 3. That could be written into some numbers plus 3, 3 added to some number, the sum of a number and 3, 3 more than some number, and some number increased by 3. For subtraction, we have the variable y minus 6. So we have some number minus 6. 6 subtracted from some number. So some number represents y. So y minus 6 first. The difference of some number and 6. And then we have 6 less than some number. Some number decreased by 6 and some number less 6. For multiplication, we have the 2a as a variable, so we could write that one into twice some number, 2 times some number, the product of 2 and some number, and then some number multiplied by 2. For exponent, it is c squared, so you could use that c squared literally the number of or the square of c, or c to the second power. For k cubed, that is k cubed, or k to the third power, or the cube of k. For roots, of course, that is the square root of x. For division, so that's x over 5, that could be translated into some number divided by 5, the quotient of some number and 5, the ratio of some number and 5, and 5 divided into some number. Okay. The key word for sum, difference, product, and quotients will indicate the answer of the respective operation. So when we say sum, that is plus, so that is x plus 3. When we say difference, that is x minus 3. When we say product, that is x times 3 or simply 3x. While quotient is division, that is x divided by 3 or x over 3. So let's try to translate. Use x for the variable if it's not specified. The product of a number and 4. Our key term here is product, so that is a multiplication. So that is simply 4x. Second, the sum of b cubed and 7. So the key term here is sum. So the operation should be addition. That is b cubed plus 7. 7 added to the quotient of x and y. So we have two operations here, the quotient and added to. When we say quotient, that is x over y, and then added to, so we added to 7, that is 7 plus x over y. A number subtracted from 8. Again, our key term is subtracted from. Our rule, you start first with the second term before the first term. So that is 8 minus x. 9 divided into a number, that is, the key term is divided into. Again, you start with the second term before the first term, that is x over 9. Next, 5 more than 2 times a number. We have two operations here, the more than and the 2 times or the times. When you say 2 times, the more than, so we have 2x is times, and 5 more than, so that is 5 plus 2x. Or you could write that one as 2x plus 5. It's the same commutative property of addition. The order does not change the expression. Next, 7 times the sum of a and b. So we have the sum and the times. When we say sum, that is a plus b. And then we have times, that is 7 times. That is 7 quantity a plus b. The operation parentheses and indicates our multiplication. Okay, the product of 5 and a number minus the sum of a number and 2. So we have here the product, minus, and sum as our key terms. When we say minus, of course that's minus. The product of 5 and a number is 5x. And then the sum of two number is x plus 2. Can we write this one as 5x minus x plus 2? The answer here is no. But instead, we could answer this one as 5x minus open parenthesis x plus 2 close parenthesis. It's very important to separate our terms using our parentheses. So the sum of a and b divided by the difference of a and b. So we have here sum divided by and the word difference. When we say difference or the sum, that is a plus b. When we say difference, that is a minus b. And then we have the operation divided by, so that is a plus b over a minus b. Let's try to practice. Let's translate the phrases to an algebraic expression. 12 less than 3 times a number. Is it A, 3n plus 12, B, 12 minus 3n, C, 3n minus 12, or D, 3 times 12? You may pause this video for you to answer. The correct answer here is letter C. Our rule, the term is less than, so the second term first before our first term. The difference of A and B decreased by the sum of W and Z. Is it A, B, C, or D? The correct answer here is letter A. Although A and B could be accepted, however, our rule, terms should be separated by a parenthesis. For equals, equals could be translated into the terms is equal to, is the same as, produces, yields, or results in. Let's try to translate the following and solve the equations. We have 15 more than a number is negative 7. We have is equal sign. We have more than could be plus. So that is 15 plus x is equal to negative 7. So our equation is 15 plus x is equal to negative 7. To solve this one, using addition property of equality, we try to add a number so that we could make 15 as 0. In this case, we could subtract or add negative 15 to both sides of the equation. So that is x is equal to negative 22. Next, 13 more than the product of 4 and a number yields 9. So we have the term yields, meaning equals. More than means plus. Product means times. So that's more than 4x and more than 13. So that is 13 plus 4x equals 9. To solve this one, we could add or subtract a number 13 in both sides of the equation. So in this case, we will subtract 13. So that would yield us to 4x is equal to negative 4. And then divide both sides by positive 4. So the answer here is x is equal to negative 1. Third example. 3 times the difference of a number and 5 is equal to 7 times a number minus 12. Again, is equal to is equal sign. We have the difference and times. So we have the difference is x minus 5 when we say times. So that is 3 quantity x minus 5. And then we have 7 times a number minus 12. We have two operations here. We have times and minus. When we say minus, that is 7x, or the times is 7x minus 12. That is 7x minus 12. So our equation is 3 times x minus 5 is equal to 7x minus 12. Distribute 3 to x and 5, so that is 3x minus 15 is equal to 7x minus 12. And then solve either the x first or the constant by subtracting 7x to both sides. So that could be negative 4x minus 15 is equal to negative 12. And then we'll transpose negative 15 to the other side. So that is by adding plus 15. That is negative 4x is equal to 3. And then divide both sides by negative 4. So x is equal to negative 3/4. Let's translate. 32 less than 3 times a number is 15. Is it A, B, C, or D? Again, our key term is less than 3 times. So meaning the second term will be the first one to be written and the second term. So the final answer here is letter B. Next, the quotient of 4 less than a number and 5 is the same as the number divided by 8. So the correct answer here is the quotient of 4 less than a number, that could be n 5, that is n minus 4 over 5. So the correct answer is letter D. The next one is the functions and relations. So we'll define a relation is a correspondence between two sets called the domain and the range, such that to each element of the domain there is assigned one or more elements of the range. So we call that one as our relation. So let's recall our Cartesian product. Let's say A has an elements of 0, 1, and 2, and B has an elements of 1, 2, and 3. Let's try to get a relation which is A cross B, or the Cartesian product. So the elements are 0, 1, 0, 2, 0, 3, 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3. That's our Cartesian product. So we define now our domain as the first value. So our domains would be 0, 1, 2, and 3. So these are our domain, our A. And our B would be the range 1, 2, and 3. Let's define a relation such that A is related to B, where X is an element of A and Y is an element of B. Let's define relation X related to Y such that X is less than Y. Okay. Among this relation, let's get 0 and 1 is 0 less than 1. 0 is less than 1. That's why 0 is related to 1. Let's say we have 1 and 1. 1, is it less than 1? The answer here is no. Therefore, 1 are not 1 or are not 1 not r is not related to each other. Therefore, if the function or if the relation is defined as x less than y, the only possible relations are 0, 1, 0, 2, 0, 3, 1, 1, 1, 2, 1, 3, and 2, 3. The rest is not defined as a relation. Next, when we say function is a special type of relation that is denoted by f of x, which is defined as a correspondence between two sets such that to each element of the domain there is assigned exactly one element of the range. So we could try to see, or we could try to understand a function or a relation is a function using the following. Let's say we have a mapping diagram. So we have figure A, figure 1, figure 2, and figure 3. So figure 1, the relation of figure 1 is a many to one relation because 1 and 2 is mapped to exactly one range, which is D, while figure 2 is a one to one relation and figure 3 is one to many relation. Now to define function, there should be only one range, exactly one range. So in our three figures, only figure 1 is a function because that is a many to one. Figure 2 is a function while figure 3 is not a function because our domain is already mapped with two ranges. So that's how to determine a function or not. You can also determine a function using ordered pair or table of values. A relation represented through ordered pairs or table of values such that x and y is recognized as a function if the x values are not repeated. So let's get the ordered pair first. So set A and set B. Among these two sets, set A is a function because no x values are repeated, while set B is not a function because if we will take a look at this one, 4 and 4, 5 and 5 are already repeated. Same goes with the table. Set A is a function while set B is not a function. Why? X is already repeated or 1 is repeated twice, so that is not considered as a function. So that's how to determine a function or not a function. For the second part of this module is how to evaluate a function. So simply, evaluating of a function is to substitute our values. Let's say we have f of t is equal to t raised to 2 plus 15t. So if you want to evaluate f of 5, simply we will just substitute 5 to the values of t. So that is 5 raised to 2 plus 15 times 5. So that is 5 raised to 2 is 25 plus 15 times 5 is 75. 25 plus 75 is 100. So in ordered pairs, the relation is 5 and 100. Now if you want to have f of negative 3. So f of negative 3, simply substitute negative 3, that is negative 3 squared plus 15 times negative 3. So that is positive 9 minus 45. So that is negative 36. So that is our ordered pair is negative 3, negative 36. That's how to evaluate function. I hope that you could answer the activities given in this canvas in evaluating a function. Next, let's do some applications of function, specifically linear equation. So let's have the problem. The forensic scientists have determined the equation h is equal to 2.9L plus 78.1 can be used to approximate the height h in centimeters of an adult on the basis of length L in centimeters of adult's humerus, the bones extending from the shoulder to our elbow. So question letter A, use this equation to approximate the height of an adult whose humerus measures 36 centimeters. In using these equations or using these problems, we need to identify first what is unknown and what is given. For letter A, we are looking for the approximate height. So h is unknown, while our L, the given, is 36 centimeters. Using our formula, h is equal to 2.9 L plus 78.1. So simply substitute 36 to the value of L. So that is h is equal to 2.9 times 36 plus 78.1. So h is equal to 2.9 times 36, that is 104.4. And then we will add 100 or 78.1 plus 78.1. So that is our height would be 182.5 centimeters. Question letter B. According to this equation, what is the length of the humerus of an adult whose height is 168 centimeters? The length here is unknown, while the height here is 168 centimeters. Again, using the formula, h is equal to 2.9 L plus 78.1. Substitute h, which is 168, is equal to 2.9 L plus 78.1. And then subtract 78.1 to both sides of the equation. That is 168 minus 78.1 is equal to 2.9 L. So 168 minus 78.1 is simply 89.9 is equal to 2.9 L. To find for L, divide both sides by 2.9. So the length of the humerus is 89.9 divided by 2.9 is approximately we have 31 centimeters. So that's how to use the given equations to solve problems. But sometimes we are not given an equation. So all you have to do is to do or to come up with your own equation. So let's have example number 2. It says here the cost of electricity in a certain city is 8 pesos each of the first 300 kilowatt hours and 13 pesos for each kilowatt hour over 300 kilowatt per hour. Find the number of kilowatt hours used by a family that receives a 519.5 electric bill. To understand the problem, let's say we used 500 kilowatt per hour. So the first 300, it will be cost 8 pesos each. While the excess, so the excess of 500 of 300 or 500 over 300 would be 200. So this 200 would cost 13 pesos each. If let K be equal to the kilowatt hour used, okay, and K would be the kilowatt hour used, the first 300 of that one would cost 8 pesos each. While how will we get our excess? That is K minus 300. So this would cost 13 pesos each. So if we will make this one into an equation, that is 300 times 8 plus 13 times K minus 300 is equal to, the kilowatt hour use is already given, 519.5. So applying algebraic manipulation, 300 times 8, we have 2,400, plus distribute this one, we have 13K minus 3,900 is equal to 519.5. And then subtract 2,400 and 3,900, that is 13K minus 1,500 is equal to 519.5. We will transpose 1,500, that is 13K is equal to 519.5 plus 1,500. So 13K is equal to 519 plus 1,500 is 2,019.5. Divide both sides by 13. So K is equal to 155.35 kilowatt per hour, or you could round this off, we have 156. Next, last example, an investor deposited 5,000 into accounts. 2 times the smaller deposit is 100 more than the larger number or larger deposit. Find the amount deposited in each account. So let's try to represent our problem. Let X be equal to the smaller account, okay. To find for our larger account, we could make use of the problem, or we could visualize the problem by, let's say we have X plus Y is equal to 5,000. Why X plus Y is equal to 5,000? Because there are two accounts. If we will join that two account, that would be equal to 5,000. Let X be equal to our smaller account, while Y would be our larger account. Now we want to make use of one or single variable only. So to get our larger account, you may subtract X from 5,000, that you would yield us to 5,000 minus X. Therefore, our representation for the larger account would be 5,000 minus X. That is our larger account. Now let's go to our equation. Let's try to translate 2 times the smaller deposit. So that is 2 x is means equal sign. 100 more than means 100 plus the larger account, which is 5,000 minus x. And then let's try to solve. That is 2x is equal to 5,100 minus x. And then combine similar terms, that is 2x plus x is equal to 5,100. And then 2x plus x is 3x is equal to 5,100. Divide both sides by 3. So x is equal to 1,700. Now let's go back to our question. If x is our 1,700, therefore, the smaller account cost 1,700. That's our smaller account. On the other hand, that is 5,000 minus x, which is 5,000 minus 1,700 is 3,300. This would be our larger account. So this is our application of our functions and equations. I hope this video lecture would help you understand module number 3. If you have any questions, you may ask through the GC or through my messenger.